Some people, like the Andaman Islanders, that's a community living in the Gulf of Bengal, see them as burning torches thrown into the air by forest spirits. Others, like some Australian Aborigines, think they're flaming sticks ridden by shamans. If you ask an astronomer though, they'll tell you that a comet is a large object made of dust and ice that orbits the sun. Arguably, one of the most famous space objects of this kind is Halley's Comet. It has left a great impact on our history and understanding of these mysterious falling stars. When this comet passed Earth in August of 1835, for example, it was blamed for the New York City fire that kept going for several nights. At the same time, the Seminole Indians in Florida saw the comet's long tail and believed it marked the day they would lose their independence. This comet came back in 1910, and people yet again saw it as a sign of bad luck. In Chicago, people bent over backward to secure their windows to protect themselves from the comet's dangerous tail. Others bought all sorts of gadgets, like umbrellas or masks protecting from comets. But what's so intriguing about this space body? How come it just pops up around Earth every once in a while? And most importantly, is it really dangerous? Halley's is what astronomers call a periodic comet. It visits us every 75 years or so. On rare occasions, some lucky people get to see it twice in their lifetime. It last passed Earth in 1986, and it is expected to come back in 2061. Despite this scheduled return, the comet's orbit can't be predicted with precision. That's partly because of the chemical processes happening inside the comet. Halley's orbit may also change due to random interactions with other planets and space objects in our solar system. Its official title is 1P Halley, and it's named after English astronomer Edmund Halley. He was the one who studied the reports of a comet nearing Earth in 1531, 1607, and 1682. Based on his calculations, he concluded that these three occurrences had been, in fact, the same comet, returning over and over again. He also predicted its return in 1758. Halley's discovery also pointed out that some comets, like this one, orbited the sun, but their journey was not circular. If you look at it in 2D, Halley's orbit looks like an elliptical wire dangling from the sun. Sadly, Halley didn't live to see the comet's correctly predicted return, but it was named after him. According to the European Space Agency, the first sighting of Halley's Comet dates back to March 30th, 239 BCE. Asian astronomers noted it down in the Shiqi and Wenshengtao chronicles. But another study claims that we might have first noticed it even earlier than that, during the times of the ancient Greeks. Writings from that period reported a huge meteor that landed in northern Greece, leaving the local population perplexed. It soon became one of the ancient world's most popular tourist attractions. But the authors also noticed a comet in the sky at the time the meteor landed. They also reported the fact that the unusual space object had remained in the sky for about 75 days. Shakespeare himself seems to have written about this comet in his play Julius Caesar around the year 1600. In this work, he included a now famous phrase speaking of comets as unusual signs, saying, "The heavens themselves blaze forth." It wasn't the last time famous writers felt a certain connection with this object. Writer Mark Twain even said in 1909, "I came in with Halley's Comet in 1835. It is coming again next year, and I expect to go out with it." Surprisingly, Twain passed away on April 21st, 1910, one day after Halley's had emerged from behind the far side of the sun. We got a better look at the comet when it last passed us in 1986. Several spacecraft were sent toward Halley's to take samples of the comet's composition. This fleet of spaceships, dubbed the Halley Armada, flew nearby, one of them taking several pictures of the comet's core for the first time in history. We also had much better telescopes to look at the comet as it swung by our planet this time. Based on current studies, there's little to no chance that Halley's Comet could actually pose any danger to our planet. Most of the bad things associated with the comet were just fabrications. Even better, comets in general may have made life on Earth possible. Specialists believe that early in our planet's history, collisions with comets brought a significant amount of water here, which helped to form our oceans. These space objects may have also gifted us organic material necessary for the formation of life. Don't confuse comets with asteroids though. Unlike asteroids, which are small rocky space bodies also orbiting the sun, comets are mostly made up of frozen ammonia, methane, or water. They contain only small amounts of rocky material. Because of their composition, comets are sometimes nicknamed dirty snowballs. Comets are made of 4 parts: a nucleus, a coma, a dust tail, and an ion tail. But their nucleus makes up most of their total mass. There are over 3,000 comets that we know of, but astronomers think there may be up to 1 billion of them in our solar system. A comet that is bright enough to be visible from Earth without the help of a telescope is called a great comet. Approximately 1 great comet can be seen every 10 years or so. People have noticed other comets for millennia. However, scientists have concluded that since comets shed a lot of material each time they orbit close to the sun, their lifespan may be only thousands of years. If you compare that to the age of the solar system, which is 4.6 billion years, it's a relatively small number. Since these space bodies are still present in the solar system today, there must be a source of comets somewhere out there. Otherwise, all comets would have disappeared a long time ago. Another famous comet is named Hale-Bopp. It came very close to Earth in January 1997. The last time it was seen near our planet before, that was during the Bronze Age, back in 2000 BCE. This comet is much larger and more spectacular than Halley's. Its nucleus stretches for up to 24 miles in diameter and can be seen from the surface of our planet with the unaided eye. Comet Borrelly was the second comet to be studied up close by a spacecraft. NASA's Deep Space One approached it in 2001 and gave scientists a detailed report of the comet's black core. This comet is surprisingly lopsided, but the reason for its unusual shape is still up for debate. Halley's comet appears to have formed in the Oort cloud at the outer edges of the solar system, but Borrelly is said to come from an icy cloud of rocks beyond Neptune, which is called the Kuiper Belt. Comet Hyakutake gave us quite the show when it passed just 9.3 million miles from Earth in March 1996. It looked like an ice blue splash with a faint gas tail. This comet amazed astronomers too, as it produced X-rays 100 times more intense than scientists had predicted. A spaceship called Ulysses passed through Hyakutake's tail in May 1996, reporting that it was at least 350 million miles long. That's double the size of any other known comet's tail. The comet Wild 2 was examined by NASA's Stardust spacecraft back in 2004. The probe managed to fly within 147 miles of the nucleus of Wild 2, giving us some of the best comet pictures to date. It was also the first time we got samples of dust particles from a comet. The precious cargo came back to Earth in January 2006. Its aim was to shed light on the conditions under which Wild 2, and the solar system for that matter, formed those billions of years ago. Wild 2 is about 3 miles in diameter and covered with craters and cliffs. When you look at photos taken from spaceships or the International Space Station that show sunlit objects like Earth or the Moon, something seems wrong. Space looks too empty. No magical scenery of a nighttime sky full of stars. It would be incredibly boring to go stargazing in space since the sky is always so dark. During the daytime, the sky on our home planet is blue because of the diffusion of light. It happens when sunlight goes through the atmosphere. But if you were on the moon or somewhere else in space, there would be no atmosphere to spread this light around. That's why the sky there would always appear black. But it doesn't mean it's less bright out there. If you were looking out of the window of the space station, you'd see just as much direct sunlight as you would gazing out of your apartment window during a cloudless day. maybe even more. When taking a picture on a sunny day, you'll probably use a short exposure, together with the narrow aperture setting on your camera. This way, just a short burst of light will get in. That's similar to how our pupils contract in sunlight so that they don't have to deal with too much light. And since it's just as bright up there in space, the process is the same when you take pictures of sunlit objects there. Using short exposure, you can get good, bright pictures of Earth or the surface of the moon, but it also means there will be no stars in the picture. Even up there, stars are relatively dim. They don't emit enough light to show up in photos taken with such settings. Our home planet has a blue sky that slowly transforms into a beautiful orange-red palette at dusk and dawn. But if you ever get a chance to watch a sunset on Mars, you should expect the opposite. An orange-brown daytime sky that gets a bluish tint at sunset. First of all, Mars is farther away from the sun than our planet. So when you're looking at the sun from the Martian surface, of course, it looks fainter and smaller. And not just that, the sun observed from Mars is just a bluish-white dot surrounded by a blue halo. The thin atmosphere of the red planet contains large dust particles. They create an effect called me scattering. It occurs when the diameter of particles in the atmosphere is almost the same as the wavelength of the scattered light. This effect filters out the red light from the sun's rays. So only the blue light would reach your eyes on Mars. How come Earth doesn't have rings? All gas giants in our solar system, Jupiter, Saturn, Uranus, and Neptune, have such rings, whereas the rocky planets, Mercury, Venus, Earth, and Mars, don't. There are two theories about how rings can appear around a planet. They might be just some material left from the times when the planet was forming, or they may be the remains of a moon that got destroyed by a collision with some space body or torn apart by the strong gravitational pull of its parent planet. The gas giants formed in the outer regions of our solar system, while all the rocky planets are in the inner part. So maybe the inner planets were more protected from potential collisions that could have formed their rings? There are also more moons in the outer regions of our solar system, which could be another reason why the planets there have rings. Also, bigger planets have stronger gravity. It means they can keep their rings stable after they form. Some experts believe Earth used to have a ring system a long time ago. A Mars-sized object might have collided with our home planet, which probably created a dense ring of debris around it. Some scientists think that this debris formed not a ring, but what we today know as the moon. There's probably a giant planet lurking at the edge of the solar system, far beyond Neptune. Scientists called this mysterious hypothetical world Planet 9. If it does exist, it's probably similar to Uranus or Neptune, and 10 times more massive than our home planet. It's likely to circle around the sun, but in the outer reaches of the solar system, about 20 times farther than Neptune. Another interesting theory says that Planet 9 could actually be a black hole the size of a grapefruit that warps space in a similar way a large planet would. Even though we once thought it was a rare substance in space, water exists all over our solar system. For example, you can often find it in asteroids and comets. It's also in craters on the moon and Mercury. We still don't know if there's enough water to support potential human colonies if we decide to move there, but some amount of water is definitely present there. Mars has water at its poles too. It's mostly hidden in the layers of ice and probably under the planet's dusty surface. Europa, Jupiter's moon, has some water too. This is the most likely candidate we know about to host life outside Earth. There's probably a whole ocean of liquid water under its frozen surface. It might actually contain twice as much water as all of Earth's oceans combined. Neptune is unexpectedly warm, even though it's 30 times as far from the sun as our planet and receives less sunlight and heat, but it still radiates way more heat than it gets. It also has way more activity in its atmosphere than you'd suspect, especially if you compare it to its neighbor, Uranus. Both of these planets emit the same amount of heat, even though Uranus is much closer to the sun. No one knows why. Neptune has extremely strong winds that can reach a speed of up to 1,500 km/h. Can they produce this heat? Or maybe it's because of the planet's core or its gravitational force. There's a monster black hole hurtling through space at a speed of 5 million Mach. Scientists located it with the Hubble Space Telescope. They believe it weighs as much as 1 billion suns. It was supposed to stay put in the center of its home galaxy, but some gravitational forces are pushing it around. At one point, this black hole is going to break free from its galaxy and continue roaming the universe. Luckily, it's still 8 billion years away from us. Solar storms are so powerful they could leave us in complete darkness. Back in July 2012, the strongest solar storm in over 150 years narrowly missed Earth. Coronal mass ejections, or CMEs, are large bubbles of ionized gas. They tore through our orbit back then. If they had caught our planet in the crosshairs, we would have literally been in the firing line. We'd have faced solar matter hurtling toward Earth, damaging computers and causing power outages that would have lasted for months. A surprise solar storm hit us on June 25, 2022. One photographer even managed to capture stunning bright auroras that flashed across the dawn sky in Calgary, Canada, and lasted for 5 minutes. Vampire stars are a real thing. They're part of a binary star, and they can literally drain the life out of the other star in the system. They do it to keep burning for a longer time. It works like this. A smaller star with a lower mass steals its sibling's hydrogen fuel to increase its own mass. This vampire star then becomes hotter. Plus, its color changes to striking blue. This way, it looks much younger. How sneaky. The color of the universe is dubbed cosmic latte. The light coming from galaxies and stars within them, as well as clouds of gas and dust in the observable universe, have a specific color. It's an ivory tint pretty close to white. The universe is beige because there are a bit more areas that produce green, yellow, and red light than those that emit blue. More than 20 years ago, back in 1999, we discovered an interesting diamond-shaped space rock. It was an asteroid called Ryugu. Ryugu. Its name is the Japanese term for Dragon Palace. There's a Japanese folktale behind that name. Basically, it's about a magical palace hidden deep underwater. In this story, there's a fisherman who visits the castle traveling on the back of a turtle. He returns back to the surface with a mysterious box. About 2 years ago, a similar thing happened in reality when the Japanese spacecraft, Hayabusa, visited Ryugu and came back with mysterious samples it picked up there. And the fairy tale doesn't just stop there. There are so many craters and rocks on Ryugu, so it probably had quite a rough past. And the craters all share a theme. They're named after something from the world of fairy tales. For example, the name of the princess who lived in this magical Ryugu castle, together with her dad, a dragon deity. Some got names after the fisherman who saved a turtle, and the turtle itself, of course. But back to the science now. So, this spacecraft took a sample from the surface of Ryugu, got back to Earth, and teams of researchers discovered something really cool. This asteroid is even older than our solar system. The spacecraft took the sample to help researchers to understand the origins of our solar system better. But this is not the first time scientists came across such ancient grains. They previously found them in multiple meteorites. Meteorites are generally space rocks that survive the fall through the atmosphere to land on Earth. They're usually rich in carbon, just like the asteroid Ryugu. But the material on Ryugu is even more specific, and something you can't stumble upon on our planet. Silicon carbide, a combination of pure silicon and pure carbon. The material Ryugu is made of is so unusual it even tells us the asteroid was formed in the outer solar system. It's one of the 3 asteroids, Itokawa, Bennu, and Ryugu, that are orbiting the Sun, but are moving relatively close to Earth. Each of them is just a loose pile of rubble, and their collective gravity is something that holds them together. They probably formed after their parent bodies collided and shattered into smaller pieces. Ryugu's individual rocks are probably 4.6 billion years old or even more, so it's most likely made up of material from its parent body, but some theories claim its surface could be 158 million years old. Ryugu sneaked into the inner part of our solar system, so we got a better chance to study it a little bit. It's circling around the sun somewhere between our home planet and Mars. It crosses Earth's orbit from time to time, which is why it ended up in a category of potentially dangerous things for us, even though it's peaceful at the moment and it really doesn't harm us in any way. It's one of the darkest space bodies in our solar system, and it's surprisingly dry. Strange, its parent body probably consists of lots of water ice. Maybe Ryugu is dry because it has flown too close to the sun sometimes in the past. That heated up its surface and dried it out, or some of its radioactive materials heated the asteroid and removed most of its water. How do we even know how old our solar system is? Once upon a time, which is billions of years ago, in some faraway, almost forgotten corner of the Milky Way, there was a molecular cloud. It fell apart and collapsed like many others across the universe did. That's how new stars form. This one formed new stars too, and one of them was a little bit isolated from the others. It collected material around it and turned it into something we call a protoplanetary disk. That's a disk of gas and dust that rotates and goes around the core of what will later become a solar system. That disk can develop into celestial bodies too, like asteroids and planets. But this disk formed the central star we today know as our Sun, 8 planets, and the rest of the objects that make our solar system. It's about 4.6 billion years old. All stars come from this pretty cool thing called a pre-solar nebula. It's once again a cloud of dust and gas that pulls material in. Later, a star forms out of it. A big outer region that surrounds a nebula is cold. A pre-solar nebula creates a protostar. It's a young star that is still not on its own, but needs to gather mass from its parent cloud. Then the star becomes independent. The material from the outer cold region then starts forming bigger clumps. As time goes by, these large clumps grow and fall in. They move around, interact with each other, and sometimes even merge or eject one another. After hundreds of thousands to even millions of years, once there's a star, the planets start forming. There were probably many objects that are gone by now, but our solar system doesn't look very different from what it was back then when it formed. Some things may have been different though. We have 4 gas giants now: Jupiter, Saturn, Uranus, and Neptune. Maybe there might have been a 5th one too. It's possible our 4 gas giants were closer to the Sun, but they migrated outwards. And what was between Venus and Mars? One theory says Theia, a smaller Mars-sized world that later, bam, collided with Earth and we got the Moon. Checking the materials of these objects, scientists have found out many interesting things when they study all kinds of minerals, rocks, and solid bodies. The composition of different elements tells them about how old some object is. They have studied meteorites that have landed on our planet. They assumed these meteorites and the Earth are part of the same system, so they calculated their potential age and got about 4.34 billion years. Rocks from the Moon haven't gone through the same processes as Earth rocks, and they're younger by a couple of million years. And the Sun, the central star of our solar system, could be a bit older. Maybe tens of millions of years older than the oldest rocks. That's how formation in most cases goes, remember? Stars first, then planets, and other solid objects next. So yes, it could be close to 4.6 billion years old. Jupiter's satellite Callisto is, as far as we know, the oldest moon both in our solar system and the universe. It's not that glamorous, just a rocky world with ice covering its surface and many craters. These craters tell us that many random flying objects have been hitting it over the past 4 billion years. That's how long we believe it's been around. Callisto and the rest of the moons around Jupiter have probably been born out of debris that was left after Jupiter formed. This all seems so old, but universe is 13.7 billion years old, so imagine how many things out there are even older than our solar system. But now, scientists have confirmed they have found one of the oldest, but also most distant objects we've ever known in the universe. It's a galaxy, G09 83808, 12.8 billion light-years away from us. It started forming within the first billion years of the universe, which also means it was that long after the Big Bang started everything. During the first 400 million years after the Big Bang, it was most likely way too hot for anything to form. So first galaxies, black holes, and stars started forming maybe within the first half a billion to a billion years. So this old galaxy could be one of the first things that ever appeared in the universe, and we get to see it. It's hard to observe it though. Scientists use a telescope to explore it, but the picture's still very blurry. It's hard to see such objects because of all those thick, gigantic clouds of dust that surround them. The Hubble Space Telescope is usually best to view distant galaxies, but there's another telescope, LMT, with a better position to look at such objects, and we can't wait for it to be fully operational to see what else it'll discover. There's this mysterious thing in space, an unusual spot that scientists haven't been able to explain for more than 15 years. There are different theories, and one of them says that maybe this is an imprint from a collision with a parallel universe. Is this true? Well, let's see. Take a look at this map. This is the map of our universe. Well, not really. This is actually the map of cosmic microwave background radiation, or simply CMB. Many billions of years ago, there was a Big Bang. It was so powerful that it created our entire universe. And of course, such an event couldn't occur without leaving some consequences. And these consequences are literally everywhere. The Big Bang left electromagnetic radiation, which we know as CMB. We don't notice it in our daily lives, but it's literally here, under our noses. And if you had some kind of superhuman vision, you would see how everything around you shines with this dim light. This radiation is very important. If we hadn't discovered the CMB, we would have never found out about the Big Bang. Previously, scientists believed that the universe had always existed, there was no beginning, and there won't be an end. It sounds pretty ridiculous to us now, but less than a century ago, people were absolutely sure of it. Stephen Hawking was one of the first scientists to guess that the universe did, in fact, have a beginning. The guy was so cool that he realized this as a student while working on his doctoral dissertation. But unfortunately, he had no proof. If there was such a strong bang billions of years ago, then where are the traces? Where's the proof? Laughed people who believed in the eternal static universe theory. But don't worry, they had the proof rubbed in their faces real soon. In 1965, astronomers Arno Penzias and Robert Wilson discovered CMB, and that was the first grandiose proof of the Big Bang. It turned out that radiation was everywhere, we just didn't notice it. In fact, at first, Penzias and Wilson themselves mistook it for the noise of a big city, or pigeons, or something else. For their discovery, which turned the world of science upside down, they received the Nobel Prize. Alright, so people learned that they were surrounded by electromagnetic radiation. Then they started collecting more data about it. They accumulated more and more info over the years until they made this very map. This is a map of CMB temperatures. But while creating it, scientists discovered something unusual. Let's take a look at this map. It looks like a large and diverse pattern of cold and warm places. But in reality, our universe is quite uniform. All temperatures on this map are close to 455 degrees Celsius with very little difference. All temperature fluctuations between these places are small, and each tiny speck actually spreads over millions of light years. So, everything in our world is pretty calm and stable. Except for one point, this cold spot right here. Astronomers first discovered it in 2004. First, it looked like nothing unusual. It's just a region where the temperature is below average for a couple of microkelvins. But remember, we're not talking about a small area. This is a giant cold region. It's literally billions of light years in size. Wait, the scientists thought, this can't be true. The universe should be consistent everywhere. According to our standard model, this cold spot simply shouldn't exist. But it does exist though. This isn't just some mathematical error. It's right there. So what is this cold spot? And how did it appear? Astronomers have been trying to find the answers to these questions for years. Even now, we have only a few theories. So let's discuss them all. Theory 1. Cosmic texture. This idea was brought up at the end of 2007. Then scientists suggested that this cold spot could be the hills of space. In other words, it may be a bumpy region of the universe, just part of its texture. But that's a silly explanation, so this theory was quickly discarded. Theory 2. The supervoid. This hypothesis was considered the most plausible for a while. It stated that the cold spot was actually the so-called supervoid. It's a terrifying, dark place of our universe with almost no galaxies. And because it's an empty region with almost no stuff in there, it seems cold to us. However, this theory was refuted in May 2017. After carefully examining the cold spot, scientists found out that there were no signs of a supervoid there. Moreover, voids and supervoids, which actually exist by the way, are still very small in size. The cold spot is literally thousands of times bigger than them, so there must be some other explanation, and there is one, perhaps the most bizarre of them all. Theory 3. A parallel universe. This controversial idea was put forward by cosmologist and theoretical physicist Laura Mersini-Houghton. She suggested that the cold spot could be an imprint from the collision of our universe with a parallel one. Standard cosmology cannot explain such a giant cosmic hole, says Mersini-Houghton. This is the unmistakable imprint of another universe beyond the edge of our own. Her assumption is based on the theory of the multiverse. This theory says that there's actually an infinite number of universes like ours in the world. They constantly collide with each other, giving each other a push, which creates a new Big Bang. So maybe the cold spot is a bruise from such a collision? For quantum mechanics, such crazy theories are pretty common. But for standard physics and our simple understanding of the world, this is earth-shattering. Of course, we need strong evidence. And Mersini-Houghton's team has begun to work on it. Professor Tom Shanks from the Center for Extragalactic Astronomy at Durham University also participates in this research. The craziest sounding of the exotic models for the explanation of the cold spot, the multiverse is actually the most standard in terms of our current model of the universe, he wrote in one of his works. So, what evidence do we need? Well, our cold spot is located in the southern hemisphere. According to Shanks, if there really was a collision between two universes, we should find another cold spot, and it should be in the opposite, northern hemisphere. If astronomers actually found it, this theory would be confirmed, and it'd become the first proof of the existence of a parallel universe. But it's not that easy. To find a second spot, we need the latest highly sensitive telescopes. We also need to find out some info about the nature of dark energy, how it affects space, and, in other words, there's still a lot of work to do. Not so long ago, scientists actually believed they had discovered the second spot. Researchers from New Mexico thought they had found it in the northern hemisphere, but unfortunately, this is likely to be a mistake. The map these researchers used had a high measure of randomness, so it's possible that their discovery is just an accident caused by other voids. So basically, we haven't found another cold spot so far despite careful analyses. But again, even the best modern equipment is not perfect, and it doesn't mean that there's no second spot, it just means that we haven't found it yet. But if one day we did find it, it could change the world of science forever. We'd confirm not only the theory of parallel universes, but also the famous string theory, and it could explain everything that occurs in our world. But if this happens, we'll get even more questions than we already have. How did these two universes collide? How does it all work? So far, it's all just guesswork. We can't claim that the cold spot is a print from the collision of parallel universes. But we can't refute this either. Actually, we may never know the truth at all, but it's still interesting to strive for it. It's dark and incredibly cold. There's no oxygen, there's no water, there's no life. But the James Webb Space Telescope doesn't seem bothered by all this. Its main goal is to find the very first galaxies that formed billions of years ago in the early universe and observe the stars making up distant planetary systems. Its mission is to… but wait, what is that? The James Webb Space Telescope has discovered something absolutely amazing, a star-planet hybrid with very strange clouds. This bizarre world, called VHS 1256b, is actually a brown dwarf. Those are bigger than planets, but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium, like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us, it appears to be dark orange or magenta. The brown dwarf we're talking about is almost 20 times the size of Jupiter. It orbits two red dwarf stars. And to complete one orbit, the brown dwarf needs 17,000 years. In fact, astronomers found out about this unusual exoplanet in 2016. But at that time, they didn't classify it as a brown dwarf, and thus couldn't explain its puzzling reddish glow. Now, thanks to the James Webb Telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Scientists have been putting forward theories about the existence of such sand clouds on exoplanets for quite some time. But the discovery the James Webb Space Telescope made is the first real proof. The silicate particles on the sandy dwarf are most likely quartz or some other mineral. In size, they're less than a micron, and 1 micron is 1/25 of a thousandth of an inch. In other words, they look like particles in smog. The exoplanet seems to have an atmosphere which contains some water, methane, and other substances and minerals. Interestingly, this atmosphere isn't still. It's constantly undergoing extreme changes. Another cool thing about it, scientists have detected carbon dioxide. And this is only the second confirmed discovery of this gas on a planet outside of the solar system. By the way, the James Webb Space Telescope, with the help of which astronomers discovered our sandy brown dwarf, is an absolutely stunning piece of equipment, around 100 times more powerful than Hubble. Even though the telescope itself is 3 stories high and its size equals that of a tennis court, its mirrors are the lightest large telescope mirrors of all time. When all the 18 mirrors of the telescope were completed during the manufacturing process, their mass was reduced by 92% in comparison to the initial discs. Each mirror weighed a mere 44 Aliyah-bas. The telescope's mirrors seem to be gold, but in reality, they're made of beryllium, steel gray, lightweight, and brittle metal. There's indeed a gold coating on each mirror. But they can't be produced entirely out of gold, since this material tends to expand and contract even with small temperature changes. That's why the total amount of gold in the James Webb Space Telescope is less than 2 ounces. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than 370 F. That's cool enough to make nitrogen liquid. A truly enormous 5-layered sun shield stretches around the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. The telescope was launched near the equator because Earth spins a bit faster there, and this gave the rocket some extra push. The telescope orbits the Sun more than 1 million miles away from Earth, and when it runs out of fuel, it'll keep orbiting the Sun indefinitely. On the other hand, even though the telescope wasn't actually designed to be serviced or upgraded, it might potentially be refueled with the help of robots. This would extend its life. Anyway, if you think that our newly found brown dwarf is the only bizarre exoplanet out there, let me show you some other breathtaking worlds. There is an exoplanet that is really something else. Just look at its awesome magenta color. You can find it in the Virgo constellation. The planet is called Gliese 504b. It orbits very far from its parent star, 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. One of the oldest exoplanets we know about, PSR B20-26b, is about 12.7 billion years old. It's almost 3 times as old as Earth. This also means that the so-called Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white dwarf and a pulsar making almost 100 revolutions per second. I bet sunrises on this planet must look awesome. Just 20 light years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming the Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's. The exoplanet also produces amazing auroras. That's why when it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf. But later, scientists got some proof that this space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet in the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create mesmerizing light shows. The next exoplanet isn't like any other. It's often called Super Saturn or Saturn on steroids. That's because J1407b has a colossal system of rings. They're 640 times as large as those our Saturn has. This bizarre world is the only planet we know about that has rings similar to Saturn's. If you moved this giant to our solar system and used it to replace Saturn, its rings would look many times larger than a full moon. An exoplanet called WASP-12b munches on the light coming from its star. It's one of the darkest worlds people know about, all because its day side consumes light rather than reflects it back into space. The egg-shaped planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. It might be the main reason for the temperatures on the surface of the planet that can rise up to 4,600 staff. The night side of the planet isn't as hot as its day side, a mere 2,200 AGRAF. The difference in temperature makes water vapor and clouds gather above the surface of the planet, and from time to time, swirls of material from the planet's superheated atmosphere spill onto its star. What a view! Discovered in 2017, Kelt 9b is one of the hottest exoplanets we know of. The temperatures there can reach 7,800 AOS. For comparison, the temperatures at the surface of the Sun reach 10,000. The planet is probably so insanely hot because it orbits extremely close to its star, Kelt 9, which is way hotter and bigger than our Sun. Experts believe that the giant star might one day evaporate the entire planet. Do you know what the third brightest object in the night sky is? If you said the International Space Station, you're absolutely right. And the coolest thing? You can sign up for a special service, and you'll get a text every time the ISS is traveling over your location. And if it happens at night, you can see it with the unaided eye. But be quick, because the station is very fast. It moves at a speed of 5 miles per second and circles our planet every 90 minutes. If you moved at such speed, you'd be able to make a round trip to the moon within a day. At the same time, the ISS isn't the fastest human-built object. This title belongs to the Parker Solar Probe that travels around Venus and the Sun at a speed of 430,000 miles per hour. On the bright side, astronauts on the ISS see a sunrise and sunset 16 times every 24 hours. The International Space Station is a true record breaker. It's the largest human-made object in space. It's 357 ft long from end to end, which is about the same length as a soccer field. It also weighs about 450 tons. 8 spacecraft can dock at the ISS at the same time. The working and living space of the station is bigger than a 6-bedroom house. Astronauts have 6 sleeping quarters, a gym, 2 bathrooms, and a beautiful 360-degree view bay window. And now, let's imagine what your life would be like if you were an astronaut on the International Space Station. For one thing, you'd be able to do some cool things there, like throwing boomerangs. Once, one astronaut threw a boomerang inside the International Space Station, and it returned to him. So just remember that as long as there is some air, even weightlessness won't stop you from having a bit of fun. On the ISS, you would never have to deal with disgusting smells. There is a specially trained person who smells everything astronauts take with them to space. It's done to protect them from unpleasant odors. The thing is that you can't really air the room out there if you don't like how it smells inside. That's why NASA is very careful about what kind of smells are allowed to pass through. You'd also have to get rid of your clothes instead of washing them after each use. To bring a mere 1 pound of load to the International Space Station costs more than $10,000. That's why it costs less to throw your clothes away when they get dirty than to waste water on washing them. While sleeping, you'd have exceptionally good airflow around you. Otherwise, the carbon dioxide you'd exhale would form a bubble around your head, and you'd get oxygen deprived. But what would you do on the ISS? Most likely, it would be space-related research. Astronauts on the station not only explore the possibility of future space travel, but also conduct all kinds of studies and explore the effect of microgravity on the human body. Oh, and speaking of microgravity, people often think that in space, you experience zero gravity, hence the weightlessness astronauts feel on the International Space Station. But that's not exactly true. Gravity is one of the most important forces that exist in the universe. Thanks to it, the moon can orbit Earth, and the sun doesn't float away from our home Milky Way galaxy. But astronauts on the ISS experience not full-fledged, but microgravity, which means very small gravity. Earth's gravity on the space station is only around 10 or 12% weaker than the gravity on the planet's surface. But astronauts are constantly in free fall. The spacecraft, people inside, and all the objects aboard keep falling forward. Not down, but around our planet, following a specific orbit. And since they're all falling together, the crew and the stuff inside seem to be floating. That's why astronauts can move things as heavy as hundreds of pounds with their fingertips. And even though microgravity is often called zero gravity, They're very different things. Anyway, on your way to the ISS, you'd be wearing a bright orange spacesuit. Its color is called International Orange, and it has the same shade as the paint that coats Tokyo Tower in Japan or Golden Gate Bridge in San Francisco. But once you reach the vast expanse of space, you'd swap orange for Snow White. The thing is, the orange suit is equipped with the stuff that can help astronauts survive if something goes wrong during the launch or landing of the spaceship. For example, a regular pumpkin suit has flares, medications, survival gear, a radio, and a parachute. As for the white, bulky spacesuits, those are EVA, which stands for extravehicular activities, suits. Their purpose is totally different from that of the orange suits. Astronauts put on EVA suits when going on a spacewalk. Such an outfit can protect them from the unfriendly conditions of outer space, with its extreme temperatures and the near vacuum. Besides, the white suit can prevent small debris from hurting space travelers. By the way, if you needed to scratch your nose while wearing your EVA suit, you would use a patch of Velcro inside the helmet. The lack of gravity also makes sneezing inside a spacesuit a serious problem. If you absolutely had to sneeze while on a spacewalk, you'd have to bend your head downward and sneeze into your chest. Otherwise, your visor would have to be equipped with tiny windshield wipers. In space, you'd often see random flashes of light, and those wouldn't be hallucinations. Cosmic rays hitting your optic nerve would create such an effect. You don't see similar flashes here on Earth because the magnetosphere doesn't let cosmic rays reach you. Before going to space, you'd have some underwater training. It's supposed to simulate zero gravity, but in fact, it has nothing in common with being in outer space. So the main purpose of this training is to see how future astronauts can deal with extreme environments. Oh, and later, during space adaptation, you might feel, let's say, weird. Around 50 to 75% of astronauts have highly unpleasant symptoms, such as vertigo, headaches, nausea, and overall tiredness. Luckily, everything usually gets back to normal within 72 hours. Before you were chosen to fly to space, you'd have to get through incredibly tough competition. According to NASA, they accept only 8 applicants out of 6,000. On top of that, the selection process takes around 18 months. If you felt homesick on a mission and started crying, your tears wouldn't flow down your face. Instead, they'd gather into thick blobs of liquid around your eyes because the water surface tension would hold your tears together. You'd have to remember to attach yourself to something before falling asleep. Otherwise, you'd easily float away from the spot where you went to bed and bump into a hard surface. That's why astronauts usually rest in sleeping bags in a small crew cabin. Another issue you'd have to deal with would be taking a shower in microgravity conditions, and it isn't an easy feat. Astronauts take a shower in an enclosed cylinder, which keeps water from floating away. They use a no-rinse shampoo, spray themselves with water to rinse off the soap, and finally, use a vacuum hose that pulls inside all the water left on their body. You'd have to get used to a dramatic change in your diet. You'd have 3 meals a day. Nothing outstanding here. But instead of sitting down to enjoy your lunch, you'd float around. Your meal would consist of some dehydrated and canned food items, and it might take a lot of time to finish it, since you'd have to be very careful not to let your food get away in the process. Now imagine needing a haircut. After all, you'd spend no less than half a year on the ISS. To change your image, you'd have to use special clippers with a vacuum attached to them. Have you heard about Planet 9? No, not Pluto. We're talking about something lurking on the outskirts of the solar system. A mysterious planet that exists in our solar system and that we haven't yet discovered. We've been looking for it for years. But finally, it seems like scientists found a key to solve this mystery. Will we finally find this ninja planet? Let's see. Planet 9 is a hypothetical planet lurking in the outer reaches of our solar system. Astronomers have been on the hunt for it for quite some time now, but it's so elusive that they've only been able to piece together a few details about its potential characteristics. One thing we do know is that Planet 9 has to be a massive world, possibly up to 10 times the mass of Earth. That's one big planet. It's also thought to be a distant wanderer, meandering through the outer reaches of our solar system. Some scientists think that Planet 9 might actually be a mini Neptune with a thick gaseous atmosphere and a rocky core. Others speculate that it could be an icy super-Earth with a solid frozen surface and a thick layer of hydrogen and helium gas. Of course, since we haven't actually found Planet 9 yet, we can't say for sure what it's like. We're not even sure it even exists. Some say it's just a myth, like the Tooth Fairy or the Easter Bunny, but others are convinced that it's out there somewhere. And at the end of the day, we're not entirely sure if Planet 9 is even a planet. It might be a special kind of black hole, or made entirely of dark matter. One thing we know for sure is that this strange object isn't hiding under our bed. The search for Planet 9 began in the early 21st century, when a group of astronomers realized that something wasn't quite right with the outer reaches of our solar system. They noticed that some distant objects, known as trans-Neptunian objects, were behaving in unexpected ways. Trans-Neptunian objects, or TNOs, are like the cosmic version of those items in the back of your fridge that you forgot about for years. They're small, icy bodies that hang out in the Kuiper Belt, beyond Neptune. So, scientists noticed that these guys started behaving weirdly. At first, they thought it might just be a fluke. But as they dug deeper, they began to suspect that there was a ninth planet lurking out there. Why haven't we discovered it yet, you ask? Well, it may be because of Planet 9's weird orbit. All the other 8 planets orbit the Sun in roughly the same plane, which is like a flat desk. However, our hypothetical friend's orbit is different. It might be tilted and move in a different direction compared to the other planets. Its orbit might also be stretched out like an oval rather than being nearly circular like usual. Because of this, Planet 9 might spend most of its time far from the Sun, like a true introvert. It only comes relatively close to the inner solar system every few thousand years. This would make it super faint and hard to spot. So the only way we may discover it is by studying the gravitational effects it has on our solar system. This wasn't the first time astronomers had gone looking for a ninth planet. Back in the 19th century, there was a similar hunt for a hypothetical Planet X. But this time, they were armed with much better technology and a much better sense of humor. They began calling their elusive quarry Planet 9, which was much catchier than Planet X. They even came up with a hashtag for the search, Pluto Lives. It was a reference to the fact that Pluto had been kicked from the planet gang, and some astronomers were eager to find a new planet to take its place. But the search for Planet 9 has been no easy task. It's like trying to find a lost sock in a laundry basket the size of a football stadium. It's so far away and so faint that even the most powerful telescopes can't see it. Instead, astronomers have had to rely on indirect evidence, like the strange orbits of TNOs, to try to figure out where it might be. Some scientists have even proposed that it might be a wandering rogue planet, which would explain why it's so hard to find. But they haven't given up hope. Till this day, they're scouring the skies, using all sorts of high-tech telescopes and fancy algorithms to try and spot this elusive planet. And fear not, dear curious human, because it looks like, after so many years of research, we may have finally found the key to solve this mystery. Astronomer Man Ho Chan of the Education University of Hong Kong has a theory. He believes that Planet 9 could have a bevy of moons attendant on the mysterious chunk of something. That's right, not only is it a giant planet hiding out in the depths of space, but it's also a bit of a hoarder. Moons are all the rage in the outer solar system. In fact, almost every planet here has at least one moon, except for Mercury and Venus. Earth has just one, which is kind of sad if you think about it. Even non-planetary bodies like Pluto have at least a couple of moons. A bit unfair, isn't it? Anyway, taking this into account, let's go moon picking with Planet 9. The region between the rock-filled Kuiper belt and the rock-filled Oort cloud, where this planet is predicted to be, should be ripe for the picking. Chan made some calculations and determined that it would be stranger if the elusive planet didn't have any satellites. According to his calculations, an object the mass of Planet 9 should capture at least 20 TNOs, as large as almost 145 kilometers across. It's like our mysterious planet is playing cosmic Pokemon with these guys. So, what if Planet 9 has moons? Would that make any difference? Kinda yes. They could give us some indirect clues to finally locate this mysterious planet. Now, you might be thinking, how in the cosmos can we possibly spot these teeny tiny moons? It's not like they're going to wave a giant flag or blast some Beyoncé tunes to get our attention. Well, apparently, the key lies in something called tidal heating. Tidal heating might sound like a new workout trend, but it's a real scientific phenomenon. It happens when two celestial bodies are close together. You see, tides aren't just about the rise and fall of the ocean. They're also the result of gravity pulling unevenly on a planet or moon. When a planet and a moon are close enough to each other, their gravity pulls on each other, creating a bit of a football shape. And as these celestial bodies move around each other, they shift shape and generate friction inside, which produces heat. Wow, who knew that Planet 9 could have a workout routine? Perhaps we should start calling it Gym Planet instead. Anyway, if Planet 9 has any moons, the gravitational pull from these moons would cause it to change shape constantly, generating heat in the process. And we might be able to detect this mysterious planet through the heat produced by those moons, even though it gives off no other signals. Now, before you get too excited, finding them won't be a walk in the park. They're incredibly small and would be very far away from us. But hey, nothing worth discovering ever came easy, right? Scientists are optimistic that with the right technology, they can spot this telltale sign. It will be easier for us to spot them with fancy instruments. Sure, the process may be difficult and time-consuming, but the potential payoff is huge. Finding this planet could explain a lot of the strange behavior observed in TNOs, the Kuiper belt, and beyond. As we already mentioned, they've been acting super weird lately, tilting and aligning in suspicious ways. But if this planet doesn't actually exist, we have yet to explain what is the reason for this strange behavior. In any case, the search for Planet 9 is one of the most exciting and intriguing quests in modern astronomy. It's like a cosmic scavenger hunt, and everyone's invited to join in on the fun. So grab your telescopes and let's go planet hunting. Who knows, maybe we'll find it sooner than we think. Hurricane alert, everyone's hiding. The speed of the wind outside is more than 75 mph. Seems a lot, but this storm is moving at 400 mph. Wait, do such speeds exist? Yes, but to see a storm that fast, you'll have to travel to Jupiter. So, let the journey begin. The planet is huge. Almost 1,300 Earths could fit into this gas giant. It's also incredibly hot, with the temperatures reaching about 43,000 EF at the planet's core. Unfortunately, you can't land on Jupiter's surface because, being a gas giant, it doesn't have any solid surface. But you can go deeper into Jupiter's atmosphere. Look at these thick brown, yellow, red, and white clouds passing by. They are what makes the planet look colorful and kinda striped. If you continue descending toward the center of the planet, you'll see its atmosphere, mostly made up of hydrogen and helium gas, become liquid. It happens because of immense atmospheric pressure. The planet's core itself is a mysterious object. Scientists still haven't figured out whether it's a molten ball of thick liquid or a solid rock 14 to 18 times the mass of Earth. Anyway, exploring Jupiter isn't the main goal of your trip. No, You've arrived here to see the Great Red Spot. It's an enormous storm raging in the southern hemisphere of the gas giant. Its top parts are towering more than 5 miles above the tops of the surrounding clouds. The storm is 1.3 times wider than our planet. In 2017, NASA's Juno space probe managed to collect lots of data about the red spot, and it turned out that this monster of a storm goes more than 200 miles down into the planet's atmosphere. That's 30 to 100 times deeper than any ocean on Earth. But these measurements are most likely imprecise, and the storm's true roots can be reaching even deeper. The Great Red Spot is colder than the rest of the atmosphere, and keep in mind that Jupiter's temperatures are 234 EF in the upper cloud layers. On the other hand, the closer to the core, the hotter it gets. Mysteriously, the highest temperatures ever recorded on the gas giant occurred in the atmosphere right above the Great Red Spot. There, the heat reached 2,400 F. This temperature is higher than that of lava on our planet. Astronomers believe that the turbulence caused by the storm might produce gravitational and sound waves that can be responsible for the superheating. But the storm itself is warmer at the bottom than at the top. People have been watching the moving vortex on Jupiter for more than 150 years. Some time ago, astronomers predicted that it would gradually slow down and become smaller or disappear entirely. But that turned out not to be the case. After having analyzed all the data received with the help of the Hubble Space Telescope, researchers were baffled to discover that the winds at the outer boundaries of the storm had actually picked up speed. The change in the wind speed is no more than 1.5 meters per hour during one Earth year. It's a tiny change, but however small the difference is, it still means a lot. The wind speed at the edges of the storm can reach a mind-boggling 400 mph. That's faster than Earth's tornadoes. At the same time, if you found yourself at the center of the Great Red Spot, you wouldn't be too impressed. The winds there move way more slowly. Scientists faced lots of challenges when they were trying to understand the mystery that was the Great Red Spot. It's unclear what fuels the storm. Can it be the nature of the storm's home planet? Since it's a gas giant, Jupiter doesn't have any solid ground, so there's no friction, which might be the only thing that could make the storm weaken. The hot gases in the planet's atmosphere are always moving, rising, falling, swirling, just like on our home planet, where cooler and warmer air mix and merge into one another, forming giant circling storms. Astronomers think that once, several enormous storms could have come together and created the Great Red Spot, and now it keeps going by constantly drawing cool gases from below and hot gases from above. Plus, the storm might be absorbing other, smaller vortices. This makes the Great Red Spot even more powerful. Unfortunately, thick clouds on Jupiter don't allow astronomers to see what's going on in the planet's lower atmosphere. Scientists have been speculating on what may hide beneath the Great Red Spot for decades. Is it a massive volcano? Unlikely. Jupiter is mostly made up of gases, and it doesn't have a crust that could crack, letting lava escape from the planet's interior. There are also a few theories explaining why the storm has its trademark color. It varies from whitish and pale salmon to bright orange and brick red. Some scientists believe the answer lies deep below the Great Red Spot, closer to the planet's surface. A colorless layer of gas might be reacting to the UV radiation coming from the sun. This is probably what gives the storm its red color, but so far it's just a theory. Hey, your guess is as good as mine, huh? Jupiter isn't the only planet that can boast having a giant storm. Another one as wide as our home planet rages on Saturn. It's called the Great White Spot. How clever! The storm has a tail of white clouds encircling the entire planet. It occurs every 30 years or so. This storm indeed starts as a spot, but then it starts stretching and stretching. Astronomers have figured out that the Great White Spot is actually a huge system of thunderstorms. At the top of the storm, lightning can flash more than 10 times per second. But the main mystery about the Great White Spot is where it gets its energy from. Some scientists think it may be powered by the sun. Others argue that the storm's cloud pattern only makes sense if there's an internal source of heat that can power the winds. Anyway, severe storms on different planets of the solar system aren't the only space mystery that makes astronomers scratch their heads. Let's move to Pluto, the largest known dwarf planet in the solar system, and explore its atmosphere. It rises really high above the surface of the planet and has more than 20 layers, all of them freezing cold and extremely condensed. By the way, our moon also has some sort of atmosphere. Called an exosphere, it consists of helium, neon, and argon. It's 10 trillion times less dense than Earth's atmosphere. While traveling through space, watch out for black holes. Whew. A black hole is a place where gravity is so strong that even light can't get out. But black holes can sometimes behave like a massive galactic volcano. From time to time, they flare up. Sounds like me, but instead of spewing lava, they produce enormous amounts of energy. And this phenomenon leaves gaping holes in the surrounding material and gas. A short while ago, scientists discovered one of the largest craters in the universe. Radio and X-ray telescopes detected a supermassive black hole that threw a temper tantrum many years ago. It happened in a galaxy cluster about 390 million light-years away from Earth. The crater this event left behind could fit 15 Milky Way galaxies. Yeah, I can't my head around that either. During your space voyage, think twice before landing on unknown planets. Otherwise, you may end up in a place like K2 141b. That's a planet outside of our solar system. At first glance, it's not that different from Earth. It has liquid oceans that evaporate, form clouds, condense, and get back to the surface as rain. But instead of water, it rains rocks. The surface of this exoplanet is covered with lava seas dozens of miles deep. The temperatures on K2 141b reach 5,000 AAF during the day. That's toasty enough for the magma in the oceans to vaporize into the atmosphere. Then supersonic winds, which can move at a speed of 1 mile per second, carry this rock vapor to the planet's night side. The vaporized magma cools down, becomes liquid again, and falls as a rocky rain. Not a vacation spot. Too hot. I'll pass.